Hello, everyone. A very warm welcome to my talk, Machine Learning on the Edge. I'm Sangeetha. I work as a developer at Amazon. In today's talk, we will see what it takes to add elements of intelligence to your mobile applications on the edge. Now, before we unpack this phrase on the edge, I want to try and summarize what machine learning is in a nutshell. It all started back when computers were invented to solve basic mathematical problems such as addition, multiplication, etc. These problems could be codified into rules and fed to computers. Computers then applied the said rules on input to give us the right output. But with time, we started working on some complex real world problems that were difficult to translate into rules. Let me give you an example. Given this image, if I ask you, is this a cat or a dog? You would be able to almost instantaneously tell me that yes, this is a dog. But how would you go about instructing a computer to do the same? We are able to recognize this because of lifelong learning of looking at dogs, getting to know them, and cuddling them. But translating that knowledge into mathematical rules for a computer to understand is difficult. And that's why there was a shift in paradigm on how we instructed computers to tackle such problems. Instead of feeding them with rules, we fed them with results. We trained computers with thousands of images labeled cats, dogs, goats, and whatnot. Computers are then able to use this treasure trove of knowledge to build models, recognize patterns, and when presented with a new image, they are able to label them correctly. That is machine learning. We train computers with test data, and when presented with new input, they label them appropriately. Traditionally, building ML solutions required developers to gather loads of test data, build models, train and tune them for accuracy, deploy them to some remote server machine on the cloud, and have the results rendered on local devices present on the edges of the internet, the client machines. But as we all know, with the passage of time, mobile devices have only grown much more efficient in their storage and computing abilities. So why don't we leverage these new abilities and flip the scenario? Instead of doing all of the processing somewhere remote on the cloud, why don't we do it locally on the device? That is machine learning on the edge. Now, what are the benefits of doing so? Not having to transfer data back and forth across the internet between the remote server and local client machine means easy latency and bandwidth wins. With all of the processing happening locally, your app and data are more secure. The results are more real time, and you are able to give better offline first experience to your customers. Now, hopefully, you're all sold on the idea that ML on the edge is interesting and want to know more about it. And today, we will see one such technology that enables this, MLKit. MLKit is Google's machine learning SDK for mobile developers. It is cross-platform and can be supported on both Android and iOS. MLKit is built on top of some known ML frameworks such as TensorFlow Lite, which is the mobile optimized version of TensorFlow, Google Cloud Vision APIs, and the Android Neural Network APIs. Now, if you're an expert in ML, you are free to choose a combination of these frameworks to solve your problem. But the great thing about MLKit is it neatly wraps on top of these technologies and offer APIs that can be leveraged with just a few lines of code. What this means is anyone with little to no ML expertise can integrate ML solutions in their mobile applications easily. The APIs that MLKit offer can be broadly classified into two types, base APIs and custom APIs. The idea is if your need cannot be satisfied by the available base APIs, you're free to build your own custom TensorFlow Lite model and bundle it along with the application. The available base APIs can be further classified based on their usage as vision-based APIs or natural language APIs. Some examples of APIs as presented here are barcode scanning, text recognition, smart replies, etc. Today's talk, I'll take an example of a base API usage and a custom API one. In this talk, the code snippets are going to be of Android, but the process is pretty similar on iOS as well. I want to also bring notice to a quick fact that the way we use MLKit has changed very recently, like I think 20 days back. Earlier, it was a hard requirement that to use MLKit, your application has to be a Firebase project. That requirement is no longer true. The first step to use MLKit is to add your dependencies. In this case, I'm taking an example of image detection, and that's why I have added MLVision as a dependency in build.gradle file. And then to the fun part, using the APIs. We first obtain an instance of the Firebase Vision object and pass in our input image to the Vision Label Detector Detect in Image API. This gives a success and failure callback. The success callback has a Firebase Vision Label object which has details about our input image. For example, when this image is fed to the API, it's able to detect that the objects here are either a musical instrument or a computer or television with the given probabilities. Now, not all of our use cases can be satisfied by the available base APIs. What if you want to recognize a bunch of Pokemons or a bunch of fruits with greater accuracy? MLKit offers support for custom use cases by allowing you to build your own custom model and bundle it with the application. To build a model, you can look up TensorFlow Hub to see if there is an existing TF-Lite model that you can use for your use case, or use AutoML Vision Edge to build your own model. With the model up and running, the way to use the custom APIs is pretty similar to the base APIs with one tweak. We need to provide the path to our custom TF-Lite model. We also have the flexibility to set the confidence threshold and the max result count. The max result count in this case is the number of possible results it can return while detecting objects in the input image. For example, in the previous image that I showed you, it gave us 3 results as either television or computer or a musical instrument. The possibilities are really endless when we use custom APIs. You can build your own clone of Snapchat by using the face detection APIs to detect faces and contours on them and apply filters on top of it. I also want to quickly mention that MLKit allows us to use on-device APIs as well as cloud-hosted options. You can think this of as a possibility to use a combination of both. When the user has access to the internet, they can use the cloud-hosted APIs. And when they go off the grid and get disconnected, they can fall back to the base APIs on the device. I also want to mention that the usage of MLKit is not restricted to native development. You can use it for React Native and Flutter as well. React Native Firebase is the officially recommended library for using Firebase in React Native. And we also have an MLKit Flutter package. Now, that is pretty much what I wanted to cover as part of this talk. As a summary, today we saw what is machine learning on the edge, what is the need for it, how do we go about achieving that using MLKit, and how do we use the base and custom APIs. I have a pretty detailed write-up of MLKit and a few other resources that I put together for this talk in the given link. If you have any further questions, feel free to reach out to me on Twitter in my handle Sangi_KP. Thank you so much.